Hello everyone. So today we are solving this problem. Make lexicographically smallest array by swapping elements. So you are given a zero index array of positive numbers. So every number is positive and the array name is nums and a positive integer limit. So in one operation you can choose any two index I and j in this array and swap numbers nums j and nums I. Okay. If the difference of them, so we have given another number called limit. Okay, so if the difference between the I and j element is less than or equal to this limit, then only we can do this swap operation. Okay, this is a condition. So return the lexicographically smallest array that can be obtained by performing the operation any number of times. Okay, so we can understand in this way. For example, this is array. Okay, and we have to find the lexicographically smallest array. Okay, I'll tell you what lexicographically smallest, but let's understand first what is supposed to do. So for example here, so when we see here 1 and 5, so what is the difference between them? Difference is 4, but limit is 2, so we cannot swap them, right? Now look at here 5 and 3, so difference is 2 only, so we can make a swap here. So what if we make a swap here? What would be the number? Number would become 1 3 5, right? It would become 1 3 5. We made a swap here. Now we had 3 and 9, so not a swap is not required, even because we are looking for the smallest, so we will try to keep the smallest number first. Okay, that is the intention, but it should be swappable within the limits. So for 5 and 3 we could make a swap, so we made, because 3 is a smaller number, so our intention is to bring it first. Okay, so now what will happen? 5 came here, and this is next number is 9 and 8, but look at here 5 and 9 is basically difference is 4, so we cannot make a swap, right? So we will still go ahead. So this is 9, right? Now we are at here 9 and 8, so we are coming to final guy 8. So what is the difference here? Difference is within the limit, right? It's a 1 only, and 8 is smaller, so we are supposed to make it swap with this guy, right? Because we are looking for the smallest number, the smallest lexicographically smallest one. So what it would be? It would become now 1 3 5 8 9. Okay, so this is basically the lexicographically smallest array possible. Okay, so lexicographically is nothing but the smallest number should be very first, then the next is smallest, but that we can make within the limits only. If this limit was not given to us, then we could have simply sort this array, right, and then we would have got, but here limit is given, so swap makes sense. Okay, so we have to make only this when limit the difference is within the limits, then only a swap is possible, and using those swaps we have to make the smallest number. Okay, so let me tell you what is the lexicographically there could be the scenarios where, for example, let's say we have an array 1 7 3 8, suppose. Then we have another array called 1 6 3 8 9, let's say. So which one is lexicographically smaller? If you look at here, even though this guy, this second one has the 5 elements, right, and first one has only 4, but if we come here, it is first is 1, so this is also 1, not a problem. But see here, second guy is 7, but this guy is 6, so this is smaller in this case, even when it has 5 elements, which is more than this guy, but still this would be the lexicographically smaller. So we have to check in this way. Okay, so this is what we have to do. Now the thing is how to do that. Okay, so before going to the solution, I will tell you one thing. You guys remember in mathematics we have the trivial solution, right? That if A is greater than B and B is greater than C, right, then A would also greater than. So guys, suppose we have the set of numbers like this. Let's say this is 8, this is 6, and this is 4, and suppose our limit is still 2. Okay, let's say I am calling our limit is 2. Now how would we do for this? Okay, so let me do that. So here it looks like 8 and 4 cannot be swapped, right? Because 8 and 4 has a difference equal to 4, so they are not swappable if we look at here. But 8 and 6 can be swappable. Similarly, 6 and 4 can be swappable. So let me do one thing. If I swap this guy, 8 this guy 8 and sorry 6 and 4, what it would be happening? It would happen like 8 4 and 6, right? This would be happening 8 4 6. We just swap these guys because these have the limit 2 only. Now again we can swap the 8 and 6, correct? We can easily swap the 8 and 6 because they are within the limits. Okay, so at any index we can swap, right? It need not to be necessarily consecutive. Okay, so what it would be giving here, it would give us 6 4 and 8, right? It is giving us 6 4 8. Now you guys can observe one thing. After coming here, we can see here we can again swap this 6 and 4, right? Because there is any number of time we can do the swap. So if we do again swap, what will happen? 4 will come at here, 6 would be here, and 8 is anyway at the end. So now you guys observed, initially it was looking like 8 and 4 cannot be swapped because their difference is not within the limit, right? We were not able to swap them. But after doing these operations, first we did this swap, then we did this swap. We are finding here that 4 is here and 8 is here. They are already, now they are swapped, correct? So now we can, why I am saying this all is like, now we can say that if we can swap in general, if we can swap A with B, okay, if they are in limit, right? And if we can swap B with C, if they are in limit, then we can also say, based upon this knowledge just be observed here, that A and C would be also swappable for the given limit. Okay, so now it should be clear. Okay, now this approach we would be using, this conceptual knowledge we would be using in our solution. I will tell you how. Okay, so we will take this one example, the one which is written over there, and then we would be solving it. Okay, so guys, what I'm doing here is I have this this array. Now I will make another array, okay, from of the same size. Let's say I have another array, I'm calling it sorted array. Okay, so what it would be, this sorted array, how it would be looking? It would be look like 1 3, would be nothing like, I will take this the original array only and I would be sorting it. I will tell you why. So if I sort it, it would become like 1, then this guy would be 3, then this guy would be 5, then next guy would be 8, and this guy would be 9, right? This is what will happen after sorting. Now what we're gonna do is, we will pick the numbers from it. Okay, on what basis we are picking the numbers? We want to basically make the group of the numbers who are falling in this limit. So we are starting from 1, right? So okay, let's say we have this one, then we have this 3. So what is the range here? 3 minus 1 within the limit, so 3 also coming to the same group. Now we are coming at 5, so 5 minus 3, that is also 2. Basically the difference, this is 2, so they are also coming to the same group. Okay, so 1 3 and 5, all these 3 guys are in the same group. Let's say I am giving the name for this group equal to let's say group 0. Okay, so I am assigning this guy to group 0. Now come to this guy 8. 8 minus 5 is 3, so this is of different group because it is going beyond the limit. So whenever we are crossing the limit of difference, like 8 minus 5 is 3 but limit is 2, that means this 8 guy should go to another group. Okay, so let's say I am making another group, this is 8. Okay, now I am coming here, this 9, so 9 minus 8, this is 2, so within the same limit, so it would also go to the same group where 8 is there. So this is another group we have found. Let's say I'm giving the name for this guy, this group is 1. Okay, so every guy 1 3 5 are residing in group 0, and the guy 8 and 9, they are residing in group 1, correct? So now as we know the trivial situation, this is coming from the sorted one, right? So whoever is in this way, 1 3 5 8 9, okay, these are like these can be swappable in the sorted way, right? So as we have already taken one example, now what we will do after getting this grouping kind of stuff, okay, what we will do is we will again go for the original array. Okay, this is our original array. Now what we will do here is, let me draw the line. So we are again traversing through this array. So let me take a different color here. Yeah, so see here, we are at very first location 1. So what is the group of this guy? 1. So the group of this guy is 0, right? This is residing in 0 group. So what is the first guy in 0 group? First guy is 1. So we will take this 1 here and we will remove it from group. Okay, now we're coming to this guy 5. Okay, so where does 5 reside? 5 is residing in group 0, right? This is the 5 and it's group 0. In group 0, what is the first guy now? First guy is 3, right? Because 1 is already deleted. So we will put here 3. Now we are coming to this guy 3. So what is the group of 3? 3 is also residing in group 0. And what is the first guy? 3 is already deleted, right? Now, so what is the first guy in this group? It is 5. So we will put here 5. Okay. We will delete this guy now. Now we are coming to this guy 9. So what is the group of 9? The group of 9 is 1. And what is the first guy in group 1? First guy is 8. So we will pick this guy 8 and we will put it here. And after putting here, we will remove it. We removed it. Now we are coming to this guy 8. So what is the group of it? 8's group is 1. And what is the first guy in the group 1? It is 9 because 8 is already deleted. So we will put here 9. Now you guys can observe 1, 3, 5, 8, 9. This should be our smallest lexicographically array. So this is pretty simple. So how we will be implementing it is like we will make two hash maps. Okay, one to keep the track of group of every number and one to keep the this group. Okay, so what it would be like, it would look like one group. We would have one hash map to group members, right? Like for one it would be like 0 group. So this would be hash map number to group ID. Okay, so 1 is in 0. It would be store 5 also to 0. It would be storing 3 also to 0. It would be storing 9 to 0, 9 to 1, group ID 1, right? Similarly, 8 would be storing group ID 1, right? So this hash map, we need the one hash map to keep the group ID of every number, and then we need another hash map like for a group ID. For example, key is 0. So 0 group ID, what is the list? It was 1, 3, 5, right? So this would be like group ID and the list of the numbers in that group 1, 3, 5. Similarly, for group ID 1, it would be 8, 9, right? So we have this kind of two hash map. So one hash map for integer and the integer group ID. Every number has a group ID. And another hash map is integer, basically the group ID and the members in this group, like 8 and 9 for the group 1, 1, 3, 5 for the group 0, right? This is what we have to do. And once we are done with it, we will traverse through this original array. We will pick the numbers and get the group of them and pick the first number and remove from that group. And this way we will be finally getting our result. So let me show you my corresponding code for it. So see here. What I am doing here, this is my sorted array. I just created for the same as this nums. I am taking all the numbers into this sorted array and then sorting it. After sorting, these are my two hash map we just talked, right? One for the integer and integer. For every integer, in what group ID they are falling, I am calling this my group. And then I have another hash map which is integer to list of the integers, right? This is the same one, like here this guy 0 ID. So 0 is group ID and this is the list of it. So for that reason I have created it. Okay, so I'm calling it group member. So for every group ID we have a list of the numbers. Okay, so these two hash map we would be using. So initially group ID would be 0, right? So we are starting and I'm putting the very first number what is the group ID for the very first number? Anyway, we are starting with the 0. So first guy I have put the group key equal to 0, and okay, and then I just created this guy, right, for first group, right, group key 0. Anyway, the first number I have put as the list. Only initially we are starting there, only one guy would be there, right? Then we are starting from the second position. Okay, so see here what we are doing. We are looking for the absolute difference, okay, in the ith and the previous I, right? We were doing in this way. We started from 1, then at 5 we were starting for what is the difference, 3 in here, 3 minus 1 we found 2, 5 minus 3 we found 2, but 8 minus 5 was 3. So same thing I'm doing here. We're starting here, we're looking for the absolute difference of the consecutive values. If they are going beyond the limit, that means this would be a new group. So I'm increasing group by 1. Same like when we encountered here at this position, 8 minus 5 was the 3, right, which is beyond the limit. So what will happen? For this guy, we increases the group. That is why from 0 to group become 1, right? So for that reason, we are increasing that. If it is going beyond the limit, that means a new group should be there. So that is why we are increasing group ID so that a new group could be created. And see here, we are putting this guy, whoever is the number and its corresponding group key, that this number has this group ID. Okay. Now what we are doing here is, if this group key is coming first time, like if it is coming first time, that means we have to create a new list for that group key. And then what we are doing is, we are adding that particular number for that group list. Okay. Now when we are done with this, we are coming out of this loop. Now what we are doing is, we are again traversing through all the numbers of nums, and see here we pick the num at I, and then we are looking at what is the group number of this number. So we can get my group dot get kernum, right? So from here we can get group ID. Now once we got the group ID, we will get the list of numbers, right? So see here, group member dot get, so we will get the what all list are there in that group, and then we are picking the very first guy and removing it. Pop means removing first guy in the linked list. So we removed it and assigned it at nums I. Same thing I was doing here, right? When we came here, we came here at 1. So what is the group of 1? It is 0. Then we came here, and what is the first guy? We popped it first guy 1. We put it here. Similarly, we will come to here 5. What is the group of it? It is 0. So what is the first guy here? It was 3. And then we will keep it 3 here. We kept it 3 here and deleted it. Same way we are doing here. Okay, so finally we are returning our nums, where our final smallest lexicographically array would be available. So let me execute my code. So basically, what is the time complexity here? We are sorting this array, right? So for sorting, it is taking n log n, and we are taking the extra space O of n because we are storing the things. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.